Well, hello everybody. Sorry for the late start, but as you can see, they've so basically, welcome to Space Oddities, and this exciting day when we're going to have the third attempted launch of the Starship and its booster to try and get this into orbit. As we just said, it's the third attempt. We're a little bit thin on the ground. It's just me and Michael, so.
Hi there.
Uh, what you look at? How are you looking forward to this, Mike?
Oh, definitely. Yeah, it's let's hope third time lucky. I was thinking earlier, um, isn't it nice to have a real spacecraft actually called the Starship?
Yeah. It's I'm sorry. I'm just just getting rid of a. That's it. Yeah. It's. I mean, we've been waiting for this. Well, we haven't been waiting that long.
No,
When you consider from their first attempt, and we hopefully will have a little bit of chat about that in a little while, to
yeah,
the second time, I think it was about 8 or 9 months. And then with this really the success of, and it was a big success. There was more
yeah,
pluses on the second attempt. Um, we've only had 3 to 4 months to
yeah,
wait
that's
this
true.
time,
Yeah,
and I know they're already talking about um, the FAA are talking about um, the next trial, number 4.
oh, okay.
So this one's got. I mean, they're quite confident about this as regards that they are they've got plans for it. They got plans for it for if it gets into orbit, and of course this is what we're hoping for, that we get this Starship into orbit, and they are actually going to be. They've actually got some test items that they want to test while it's actually up in space. And I hope you can see this because it's not a very good script. But I'm just going to share my screen. This is a right. This is the this official SpaceX spiel about what's happening today. And what you can see in the one, two, three, fourth paragraph, it says the third test flight. Um, the third flight test aims to build on what we've learned from the previous flights while attempting a number of ambitious objectives, including a successful ascent burn of both stages, opening and closing the Starship's payload door, which has been the first time that they've actually opened it in space, a propellant transfer demonstration during the upper stage's coast phase in orbit, and the first ever uh, relight of a Raptor engine while in space,
Hmm.
and a controlled re entry of Starship. It will also fly a new trajectory with Starship targeted to splash down in the Indian Ocean. Of
Hmm.
course, the others were scheduled to splash down just off the coast of Hawaii. This new flight path enables us to attempt new techniques like in space engine burns while maximizing public safety.
Mm.
So they've got a lot planned. They've got obviously they're quite confident if they're going to try this in on this attempt. We are all got our fingers crossed, toes crossed, everything crossed. I mean, got a plait down my back because it's all crisscrossing. But yeah, it's absolutely it's astonishing, and I hope that we're in this position that we can actually move forward now and get because of course this is very very important for Artemis, isn't it, Michael?
Of course it is, yeah, because obviously we're looking forward to the lunar Starship when that shows itself eventually. I believe that it's already working on it. In fact, I saw something last week, I think it was, about them testing a docking mechanism for the lunar
Yeah,
Starship
exactly. Yeah, I
for,
saw that.
for Orion, of course, So, yeah, that looks to going in progress very well. Yeah.
Yeah, exactly. Well, what I'm going to do is we'll just take this off for a second.
Mm.
We'll go back to, there we go. As you can see, that's the Starship sat on the top of the stack.
Mm.
They're moving ahead. The poor quality of the film is because it's foggy there, and also it's still dark.
Yeah.
This will actually, if it, well, it won't now, but there was a chance that it was actually going to launch in the dark, which would have been amazing.
Yeah.
Get those 33 Raptors lighting up the whole area.
Yeah.
There is a lot of cloud. Um, and as I said, we've already said about the fog. We know they're not shy of launching in the fog because, of course, we had SN11. You can remember that, Michael, when they launched that into the fog?
Oh yeah.
We couldn't see a thing, but all of a sudden we saw lots of flashing, and then a rain of debris everywhere. It's
Oh gosh. Yeah.
you remember that one, and
Yeah. That's nice. Yeah.
all the cameras were being smashed and everything. Um, but as you can see, if you look at the countdown clock, they've pushed it back by an hour or so.
Yeah. I think
I
that.
think we're on to 50 odd minutes, are we?
Oh,
I can't see. I've got something over the
yeah.
top of
So it
my.
should be daylight by then.
Yeah, it's so it's very they've, like I said, they've had to push it back.
Mm.
So what we will probably do is we'll have a little bit of a chat now.
Mm.
And then what we'll do is we'll leave the stream up so people can watch what's going on with the sound.
Yeah.
Um,
I was just going to say, night launches are very nice, but not very good for photography, really.
no, but what they were hoping, what a lot of people were hoping, is that because of it being a night launch, and then of course once because it's on dawn, it will be dawn
Yeah.
when they come up. Is that as it gets so high, you may get what they call the jellyfish,
Oh, that's right. Yes. Yeah. Yeah.
where the actual exhaust plume expands and then it's caught by the sunlight, and you get this literally massive domed jellyfish effect where it lights up all the exhaust and that. So there was a lot of people who were hoping for that,
Yeah.
but possibly it'll be probably maybe a little bit too late now when now
Um,
they pushed it back an hour or so.
I mean, I remember that the one and only space shuttle launch I ever saw was a night launch, and it was absolutely amazing.
Yeah,
That was STS-61 in December '93. Absolutely amazing that was.
yeah. I'd just like to. I see we've got some people actually joined us. It's lovely to see you. Thank you for joining us. We thought we were going to be alone. Pop your names up in the chat if you can. I see. Well, Michael's here. I can see he's up and running. Hello, Sandra, and hello, Kev. Nice to see you, Kev. If you're in the watching now, please pop your names in the chat so that we can just say hello to you. And the more the merrier, the more the merrier. So what we'll probably do is because we've got quite a bit of time to kill, we'll just have a quick chat about this. Like I said, I put up gave you just a brief rundown of what this flight actually will entail. And as I said there, I think Elon was quoting something like 80% chance of full success this time. But they, like I said, they are more confident that this is going to reach space because they've got plans to do some more experimenting and demonstrations when they get up there. And of course, the main one is the fuel movement, distributing fuel between tanks, because of course one of the main things, and we were talking about Artemis, is that we know that there'll be the lunar starship, which will be taking the astronauts down to the moon's surface, but also for it to be able to stay in space, because that will never come back and land again. For it to stay in space, it would need to be refueled. And one of the ideas is they're going to use sort of like 10, I think it was 10 to 12 starships to go up into space and actually refuel it. And there's Alan's just thank you, Alan. Alan's just put up. Let me just pop this up.
Boats in the exclusion
Yeah,
zone.
boats in the exclusion, hold up refueling. Well, that's very rude.
Yeah.
That's very, very rude. Don't they know what this entails? So yeah, we'll definitely I'll be writing to my MP about that. Yeah,
Or even your senator.
yeah. Thank you for that, Alan. Thanks for the update. We're running several things here. We're a little bit flustered. If anybody watched the show on Tuesday, I've been in mid Wales and I've had to come back today and try and get everything set up. And as you can see, we're a bit thin on the ground. Everybody else is working and they've got other things because this is something else, wasn't it, Michael? This was sprung on us.
Yeah.
We've had what was it? Probably a week at the best.
Yeah.
When they said that they were going for the 14th, and of course, one of the reasons they're going for the 14th is it's some sort of anniversary for SpaceX.
Oh, right.
It's an anniversary of I don't know whether it was its first ever launch, or whether or not it was sort of like one of the test flights of one of the original starships or something like that. So they were hoping this is one of the probably one of the it's not the main reason, but this is probably one of the reasons why they aimed for the 14th.
And the other thing about the 14th, it's also known as Pi Day.
Oh, okay. Oh, yeah. That's not apple pie.
No, not apple pie. 3.14.
Yeah, 3.145. Blah 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 blah. Whatever it is recurring. Yeah.
5926536.
Sorry. Yeah, that magic number you need to work out the length of a circle, of the outside of a circle, and all that. Right. So yeah, curvature. I can remember something vaguely about it, but yeah, but mathematics was never my forte.
No, not mine.
So yeah, but it's Pi Day. Oh, okay, then fair enough.
As in PI.
Yeah, as in PI. Yeah, of course. One of the famous quotes of Carl Sagan talking about pies. I mean, I'm going off a slight tangent here. Was that if you want to make a apple pie from scratch, first you have to create the universe. Which is true. You can't deny that logic.
No, yeah.
So you'll have to wait a few years for all the elements to get made and be able to join together, and so you can make an apple tree and things like that. But
you can use that quote for anything, couldn't you?
Exactly, and it's just one of those things. So yeah, I can't remember what we were talking about now. I think we were talking originally. Anyway, thanks for that update, Alan, because if anybody else sees anything, just pop it in the chat. So you're keeping us informed as well. As I said, we're a little bit tad thin on the ground, so we're trying to monitor lots of things here at the moment. But yes, it's a very exciting time.
Apparently, there's trouble with some people trying to get in on YouTube.
Sorry?
Apparently, there's some trouble with people trying to get in on YouTube.
Is there? Okay, then.
One of them was Rachel.
Right. I've just noticed that the actual stream had stopped, so I've started it again. So let me just. There we go. We're up to date. Oh, it's gone daylight. So I'm just returning. I hope that's running now. People are having trouble getting in on YouTube.
Yeah. Right.
Well, someone's trying to come in on the. Let me just do
I
this.
got in okay.
Yeah. Oh, it's Bernard. Bernard.
Oh, Bernard.
Let's just let Bernard in.
Oh.
Yeah. So.
Hi, folks.
Hello there.
Hi there. Why am I not showing?
The invisible man.
Let me try again.
You're showing your red pizza at the moment.
Right. I've just got a message from Dave. He said, "What's hi guys? Just got in. What is the latest on the launch?" Well, the launch has been pushed back. Apparently, there's a couple of reasons. One is they've got lots of fog, as you can see by the stream. that it's very, very foggy there. They've got lots of cloud cover, and they've actually pushed the launch back by about an hour. So at the moment, we're just sort of like killing time, kicking our heels, and just waiting for this exciting, hopefully successful launch. We were talking briefly about what they expect. They're expecting 80%, I think they were looking at. Kevin, what NS feed are you using there? It's just on YouTube. It's National Spaceflight Live. And the best thing to do is search for a NASA spaceflight, and then click on their icon, and then it should be the first thing that comes up if you're looking for it, Kevin. Yeah, because there was one that was just showing a live view of the launch site, but that's just their standard thing. Hello, Bernard. How are
Hello
you?
again, guys. Yes, I'm good. I'm good, thanks.
Yeah, we're down to. They've pushed it back a little bit more, unfortunately. I hope you can stay for the flight, but
Hi, Bernard.
Hi, Michael.
we've got an incursion of boats into the exclusion zone, so that's held up refueling, or fueling of the actual rocket itself. We're sort of kicking our heels, and yeah,
still a lot of cloud there, though, isn't there?
Yeah, you're welcome, Kev. I hope we got in well. So we were talking, Bernard, about what they're expecting from this flight, and even Elon Musk is saying he's pretty confident that they're about 80% certain that they're going to get this into orbit this time. In fact, they're so confident. Well, the confidence is high enough that they're actually going to do some demonstrations of certain products and things. One of them is to open the actual payload door for the first time in space, to demonstrate that it can be done. One will be is to pump fuel from one tank to another, which of course means that they're going to be moving fuel from one end to the other end of the ship. And of course, this is required for when they start their refueling of the lunar starship. Hello, Roger. I've just seen you popped into the chat. So that's two of the demonstrations. One of them, they're going to reignite a Raptor engine for the first time in space. That's never been done before. In fact, actually thinking about it, I don't think Raptor engines have been in space at all, have they?
Good point.
Yeah, so of course it'll be the first time. It's the first time they'll actually ever been in space.
Just read Daz, that launch time is now targeting 1:10.
1:10.
Because they're trying to move the boats out the way.
Right. Okay. Well, they got torpedoes, haven't they?
Yeah, exactly.
Yeah, we'll take them out. So yeah, torpedoes. Yeah, take them out first.
So I have a question. Folks.
Go on then, mate.
Yeah, I'm not going to be able to stay very long. It's perfect because it's lunchtime, and I thought I was going to be able to see it because I'm working at the same time, so I'm not going to be able to stay. Unfortunately, potentially until the launch. However, I have a question, and it's related to. I remember reading that. Starship is, one of the objectives is to be used for a lunar ship, that would go to the moon and potentially land on the moon and deliver payload, right? And people. So I remember reading that the thrust of, when Starship would want to try and land on the surface, the flames and the thrust of of the engines would actually potentially dig a hole through the surface as it's trying to land. Is that true or not? And if so, what are what are they thinking about? Are they going to like add additional thrusters on the side to prevent that hole? I don't know. I'm just something I've read.
Do you want to take that, Michael, or do you want me to have
Well, that's a good question because I'm not really thought about that myself. But going back to Apollo, I was watching something the other night. The descent engines on the lunar module hardly made a dent in the surface.
Yeah.
But this is completely different setup, isn't
Yeah.
it? You know,
And it potentially depends where you're going to land as well, and the composition of the surface, right?
Yeah,
And
composition of the surface. Yeah, that's a good point actually, because
because one of the actual hello Lou, thank you. I was going to say from the USA, but of course you're in Florence.
Yes, he is.
So I hope you're having a nice time out there and it's nice and warm for you. Yeah, going back to the Odyssey, Odysseus, sorry, lander, Intuitive Machines actually had a NASA experiment on there, which was supposed to, as they landed, it was going to kick up the regolith and everything else.
Yeah.
And they had spectrometers, lasers, and everything that was going to actually analyze what was kicked up, what the regolith consisted of, and how it interacted with the actual exhaust. So, so that was one of the reasons that one of the I think they probably did get some data from that, but of course not as much as they wanted to, because unfortunately it was moving sideways too fast and it broke one of the legs, and that's why it tipped over. So yeah, that's an interesting question, that is, because we didn't get sort of like what we wanted to see. We're not sure, again, as you said, how deep the regolith is at the South Pole. Because remember, this is where we're going, to the South Poles, because as we said before, the Apollo landings were all around the equator, and they were all in what we called the mare, or the seas, which is new surface. It's all volcanic, and basically it's there. Most of it is big craters that were created from the late bombardment. What was it, 4 billion years ago, 4.5 billion years ago? While it was still malleable, it was being hit by these big meteorites, and the lava was coming up and was filling the craters that were formed. And of course, over time, as it got cooler, it solidified, and that's why the mare seem to look very smooth. They're not, but they do look very, very smooth.
And of course, sorry. And of course, the South Pole is completely different.
That's right.
Crazy. Obviously, lots of meteorites have hit in the past. Chucked material out of the surface and that. So you don't know how it'll stand up to land.
Of course, the sort of like North and South Pole is what we call the old surface. It's basically it tells the history of the moon itself and how it's been bombarded constantly, but of course at the North and South poles there was no lava flow, so it is really, really rugged. If you go to look at a map of the moon or look at any of the pictures of the moon, then it is very, very rough, very cratered. And this is why they were also, when we were talking about landing on the moon, all the landers that have actually gone to the moon just recently are all using things like, it's like facial recognition tools. They've got so many photographs and they've built up a library that they're using sort of like a facial recognition thing, so that it can look at the surface as it comes in and recognize exactly where it is, because precision is going to be more important landing at the South Pole because of the conditions of the how rough and rugged it is. You're not going to have sort of like the big areas like the Apollos did, which would be considered, if you got within several miles, that was a good landing for an Apollo. But here you're literally talking probably about 200 or 300 meters. You
Yeah.
don't want to be too far off, or else you're going to be um, uh, sort of like but you'll be in trouble. You'll be in trouble,
Yeah. Of
as
course.
we've seen with the recent landers. The
Mm,
Japanese lander unfortunately tipped over. It was on a slope.
yeah.
As I said, the Odysseus lander, unfortunately, which, I mean, I'm not being funny, but these, both Slim, which was the Japanese one, and the Odysseus, were successful in doing soft landings, because
Yeah.
they were still able to operate the instruments on board. If they totally crashed, then you wouldn't get nothing back from it. Um, so they are been successful in a soft, how can I say, a soft crash, or something like that. I don't know how to put it. Um, and we are so we're getting there. We're getting
Mm,
there. There's, of course, there's 2 or 3 more, I think, moon landings planned for this year.
yeah.
And hopefully we can get it all sorted, and get on the moon, so that we can also get astronauts
Yeah.
uh, um, very, very soon landing safely themselves on
Nice.
the moon themselves. And of course, this is what this is all about. As Bernard said, of course, we're using the Starship, the lunar Starship, to land. And I think we were talking about the refueling that it's going to be. I think it's about between 10 and 12 starships would have to launch from the Earth, go up into space, and refuel the lunar starship,
Yeah.
so that it can carry on um, its task, basically, of taking the astronauts down to the um, the surface. But the thing is, I think, isn't the Starship only? Um, I think there's one demonstration, isn't there? There's an unmanned demonstration landing.
Yeah.
And then there will be the next one will be the landing itself.
And
With
are they not going to do a lunar flyby return um, like Apollo 8, for instance?
I don't know. I can't remember
No, I
seeing
can't
one.
actually.
I can't remember seeing one advertised. I think it's basically they're gonna fly one out there,
Mm,
do a landing, and then take off again. And I
mm,
think basically that one, once it's done its thing, it's just gonna be in lunar orbit forever.
yeah.
And then we're going to send up another one, which will then actually do the landing with astronauts on board. So yeah,
Mm,
it's exciting times. We
yeah.
need to get back to the moon. We've got to get this right, because once we get this done, then we can think about possibly moving out a little bit further,
Mm,
which again will bring in new challenges.
mm,
So it'll be extended space flight times and things like that.
yeah.
So yeah. So what do you hope that we will achieve then, Bernard?
Well, I mean, from my point of view, the main argument here, of course, is to lower down the cost of launching payloads into space and sort of
Mm.
democratizing it. I'm trying to say that
Yeah.
properly. Yeah, so that everyone can potentially have better access to space. And I mean, what I'd definitely like to get out of this is maybe less the human exploration side, but more the ability for us to be able to have the capacity to send more spacecraft and heavier spacecraft to carry on exploring the solar system. We are very limited in launch capabilities and weight restrictions. And even though now, of course, you have Falcon 9 and Falcon Heavy and all that, and that's great. But I wish we had, I wish space agencies had more choices, at their disposal in order to be able to really create fantastic spacecraft that would go, or space
Yeah.
missions. And that's one thing that I would like to see out from this.
Yeah. Yeah, I totally agree. I mean, it seems that the innovation, and it's taken NASA far too long to realize this, comes from the private sector.
Can I announce a news flash? Does
Go on then, mate.
Starship team is the Starship team is going for prop load, but keeping an eye on winds. Now targeting 8:25 Central Time for liftoff. So that's 1:25 our time. So
1:25.
Yeah.
So we're basically back to an hour again.
Yeah, basically.
Yeah. So it's unfortunate that we've got all these hassles. The thing is, I think today is possibly the worst day that we're going to be looking at. They've got 2 more days of road closures and all the notices that they need to go out. The FAA license, which only arrived last night, quite late, gives them today, tomorrow, and Saturday, and I think also the 18th, which is the Monday. I think tomorrow again it's another 2-hour window, but Saturday it's only an hour's window, and then Monday I think it's possibly 2 hours. So they are covered by the license for a launch over the next 4 days. So hopefully we do. I would prefer, if just for the sake of actually for us viewing it, I think that we need to get this thing off the ground, but when we can actually see it. I think the stream stopped again by the looks of it.
Oh right. Yeah.
Let me just bear with me. It has as well.
If it's delayed by an hour, I'd recommend that I would personally go and have my lunch now. And
yeah, I think what we will probably do is we will because they have got venting, so they have started refueling. That looks like the fast on the right hand side. That's the fast disconnect our area. I do believe. I can't really see through all the smoke and all that.
Yeah.
So it's things are moving ahead.
Yeah.
But as we said, there's no guarantee this thing is actually going to launch today. We really do hope it does. And all success. But I'd be quite. But as we said earlier, they're not shy of launching in adverse conditions. SN11, as we remember, we saw it take off, and the next thing we knew, we saw bright flashes, and then everything was being showered with debris because we couldn't see it in the fog. Exciting times, dangerous but exciting times.
Yeah.
So I think what we'll do is I'll leave the stream running. I'll turn the sound up so we can actually see it, and then we'll keep an eye on things, and we'll pop in occasionally just to keep people updated. But we'll sort of like give ourselves a bit of a break, and have a coffee and things like that. But then we can pop back and see how things are progressing. And I hope everyone will be able to stick with us. It's as we said, these things do happen. They're hedging their bets with the weather, with the cloud cover, because there is, I think it's 100% cloud cover. And there is fog, and of course now they've got the boats messing about. So obviously they've got them to move out the way, or they're on their way out of the way, or else they wouldn't have started loading. So if everybody's happy, we'll go and get ourselves a coffee. We'll keep an eye on things, and then we'll pop back. What did we say? 1:25 is the target launch time. So if we pop back in about, as I said, I'll keep popping back in just to keep people updated, and then we will pop back about sort of like 10 past.
Yep.
10 past, quarter past. So
that'll be fine.
Yeah, I will turn the sound up on the stream so we can enjoy what the space flights are talking about, and we will be back later. So please stick with us, everyone, and we'll see you soon.
We've been finding is that Alex and Adrian here have been predicting slips in the launch schedule here because of what we're seeing or not seeing here on the pad. So I'm seeing, of course, a lot of venting coming out of the middle of the tower. Alex, what does that indicate?
Yeah, and I should say this is not an exact science, right?
Right.
Sometimes there's still some leftover things that they need to vent out of that tower. So even though, especially if they start with a slow fill kind of thing, I can imagine that it doesn't do a one-to-one kind of correlation of whenever the tower vent actually goes out and disappears, then that's when they load. It is usually an indicator of that, but sometimes, in reality, the actual flow of that liquid oxygen may be that it has already been going into the ship for a couple of minutes prior to that. We see a similar thing with the Falcon 9, where even when they start the liquid oxygen load on the
Hi,
second
Andy. How are
stage,
you?
and that's
Hello. I just thought I'd drop in and say hi
Can't hear you, mate.
very quickly.
doesn't completely
You
disappear.
can't
We
hear
see
me.
some of some remnants coming out of it, and basically leftover of that liquid oxygen coming out from it. So, we're essentially approaching that time in the countdown, but these sort of vent guessing is not an exact science, as I said. So there's always some leeway in terms of the minutes here. Tends to be like plus minus 5 minutes or so, I should say. It is good as a general indicator of whether we are on progressing correctly or not, but not always an exact science on whether the
Can you
all
hear me
of
now?
the vents come out
Yeah.
at an exact T0 on the count and things
Can
like
you
that.
hear me?
That obviously only
The
SpaceX knows.
sound
and,
from NASA space flight is
that would
stuttering
be
a
great
bit.
to know, but
Is
obviously
that stuttering from your end?
their own proprietary
No, it
stuff,
sounds
so
as
we
clear as a
respect
bell
that,
at the moment.
obviously.
And the system is
Let me
evolving
just
in
check.
each iteration here too. So the
You
timeline
probably
might
find
change a
actually
little bit.
that
The
the being
fueling
here and the
time
talking.
in which the time it
Let me
takes to
just,
fuel this rocket up has dropped significantly. So they do have a little more flexibility.
I'm sorry, I have an update. Can we go to the white view
Sure.
again?
Oh yeah, now the tower
Yeah,
vent
because
here.
the tower vent has stopped, which means
Okay.
most
That is-
likely, Starship is in fueling for the third flight test.
All right, here we go. So this is it. They're committing.
That is definitely confirmation of that, and as you can see, there's still some remnants there. You can see it's a bit venting, like a little bit of a fume there, just very slightly, but that is to be expected. Obviously, there are some remnants there of that liquid oxygen, and boy, we're into.
So what we're going to be.
mode.
What we're going to be looking for now is that
Now
condensation
official.
and frost to develop, right?
SpaceX has.
And we have a
confirmed they are
confirmation.
on load.
Yep. All right, so they are definitely loading prop, and we saw that first before they announced it. See that? So our team knows their stuff here. So and so what we're looking for now is that frost.
Okay, I just
buildup on
popped
the
in to say
outside
hi.
of
Hope
Starship.
everything goes well. I'm going to go now.
The upper stage is now
So,
loading.
fingers crossed
Again,
for
they
a
start
successful
the
flight.
liquid oxygen load first, and then the liquid methane load 2 minutes later. The first thing we would see is the frost ring at the bottom, close to the ship QD.
Yeah, it
you can
sounds
see the
good
ship
on
QD there
YouTube,
going
Andy.
from
It's
the
okay.
tower to the ship. And right at that area, we will see
Just say hi
a
to
frost
Andy.
ring forming very, very soon. That's basically the area of interest right now, where we are having a close eye on, because that's the first frost ring that will appear on this vehicle. And it actually should appear any second now. That's at least my expectation. Like, usually this goes pretty fast. Once they are going into fueling, this basically happens in minutes.
And
yeah, we'll just start
Alex,
seeing that frost soon.
Alex, what does this mean for the
Yeah.
tiles on the outside? Because we're going to see the frost build up, obviously across the entire Starship. But the top of the rocket, which is what's facing us here, which will be the top when it gets into orbit. The top is just stainless steel essentially. We'll see the frost build up there. The temperature change on the surface of ship must impact how those tiles stay attached. Is that part of the challenge in keeping those tiles from popping off? Because it's a big
Indeed.
state change to go from room temperature or outdoor temperature to freezing.
Yeah, it is indeed quite a challenge. And then when you have the re-entry, you have on one side the cold tank, and on the other side, you have blazing hot plasma, right, heating up the tiles. So you don't only have a sort of gradient of temperature over time as you load that cold propellant, but also even in physical, in like the physical state of the tile. On one side is super cold, and on the other side is super heat up. So it is quite a complicated challenge in engineering wise, right? And so everyone that thinks that, oh, why don't they do this? This is so simple, right? Well, maybe it is not as simple as you can imagine, right? This takes a lot of work to do, and sometimes the best solutions don't seem to be the most obvious ones. A lot of people, for example, come up with the idea of why don't they put a single tile that is the size of the windward side of the starship. But then it's like if it gets damaged, that's the only heat shield that you have, right? If one tile of the current ship gets damaged, that's one little piece of the total area that you get damaged instead of like the entire thing. Whereas what we're seeing right now is that they seem to actually be going the other way. They're trying to go to smaller tiles, at least for some parts of the vehicle, perhaps for version 2 of a Starship. So we've seen some development tiles being used on future vehicles. So that is an upgrade that we'll see in the future, obviously, not on this flight, but good to keep in mind for future flights, and when you guys tune in again with us to see those flights, of course, here on NSF.
And if you're just tuning in, because we have a bunch of people that have joined the stream since the last time we gave an update, we believe, about 46 minutes away from the liftoff of Starship. We have more confidence in that we're nearing a liftoff because fueling of Starship has begun, beginning with the Starship at the top and then followed by the booster at the bottom. And Adrian, why do they fuel it in this way? Why not do the whole thing at once?
It's an interesting question because I feel like the full answer is not actually what we know, but there's a high likelihood that it is because of these tank farm upgrades, and it just turns out to be the way that the booster now is a bit faster to fuel up because sorry, we just got a close up and then I'm always getting curious. But basically the booster just got a lot of committed resources from the tank farm, and maybe that just makes it a little bit faster to fuel, or like 10 minutes right now, and that's the reason why they start with the ship now. It's basically just the tank farm logic that arrived there.
And so we're still awaiting some frost to develop on the outside of Starship as fueling has begun, according to SpaceX, so we will keep an eye on things. Hey, I had a super chat question here that I thought would be interesting to answer, and maybe I'll toss this one to Alex. Juan Lambers wants to know, there are lots of aircraft flying above Brownsville per Flight Tracker 24. Could this cause any issues for launch? And I would imagine, just like the Mariner notices, we also have no-fly zones here too, so you could probably safely fly within the proximity, provided you don't cross into that zone, right?
Yeah, I just got notified. Thank you, Ryan Weber, in the back channel. It looks like the oil and vent has stopped, which is usually an indicator that propellant load has started on the booster. So we're obviously gonna wait for SpaceX to confirm that officially, just like the last time when we said this is the indication that the ship load has started, and then they tweeted about it. So we're gonna wait for that. But I'm gonna answer your question here about the flights over Brownsville should be good, because the TFRs, the temporary flight restrictions, and basically all the NOTAMs, the notice to air missions, those are over mostly over the ocean and over the launch site. So Brownsville, fortunately, is far enough away, at least, that it is not within that area, that zone, so those should be good to go. And frankly, probably Brownsville Airport, it's not a busy airport, but they're probably thankful that it doesn't cover the airport like on other. And there we go. We just got the confirmation. Propellant load of Super Heavy booster is underway. So
can we go to the ship? Can we go to the ship? Yeah, to the close-up on the ship QD, please, if that's possible. I see a frost ring, I think.
Yep.
There it is.
There it is.
Liquid oxygen is being loaded. liquid oxygen is being loaded onto Starship.
We get very excited about frost and venting here on, on NSF because it is an indicator that things are moving in the right direction. So, so what's happening right now? Boosters getting fueled and shipped?
Yep.
Yes.
Both are being loaded right now, which is great news.
And Adrian, how long does it take to get the fuel in? Because that's obviously a factor here in making sure you hit the window.
It's an interesting because the OLM vent, and that's what Alex kind of hinted at, that these venting stopping and everything is a bit of a it's an interesting indicator, but not always perfectly lining up. Because, for example, the OLM vent here stopped way earlier than actually where they would start booster propellant loading, because it stopped around 43, 44 minutes, but actually they don't start until 42. So. If this time at the top is still correct, and I believe it is, they are now progressing still to this estimated T0, and it takes 53 minutes for the ship from basically propellant loaded to T0, and they will start the boost at 42 minutes. So this is where we are right now. So both stages are now being loaded.
And even if they're not certain they can get off... Sorry, go ahead, Alex.
Yeah, I was gonna highlight what you said, Adrian, that it looks like they may have tweaked a bit here the start of these loadings on both vehicles. It is pretty much still what they have published, but just off by a few minutes here and there, and based on the previous. It's completely normal though that when based on the previous data and the previous flight, and there's also a new tank farm, right, with all of those new additions and things like that. That they tweak these things much closer to the liftoff, and so not unexpected to see this. We saw a similar thing with Flight 1 and Flight 2, where some of the timings did not correlate with what they had put on their website. Mostly probably because again, they try to go and tweak those things as just as in the flight, not really because it's on the ground, but you know what I mean.
All right, and we are looking at Starship Flight 3 in fueling mode right now. So we are about 40 minutes from what SpaceX says is the T0 launch time. They still have some margin in the launch window here, which extended from 7 a.m. Central Time to about 8:50 a.m. Central Time, if I'm not mistaken, if my math is correct, 110 minutes. The fog you are seeing there is from fueling mostly. It was a very foggy morning. That fog has dissipated, but now we've got space fog generating from ship as it gets fueled. We've got super chilled fuels going in. We've got humid air. So just like a soda can, you're going to see ice building up and condensation all around. It's going to look pretty cool. There's a nice cloud on the ground that we saw from some drone shots on Ship 2 that we watched not too long ago. So that is what's happening. We are feeling pretty confident that SpaceX is going to try to push to launch here because they are fueling the rocket. It does take some time to do that. And Alex, we got an update?
Looks like the booster is already frosty. I see some frost lines. There you go. Thank you, operator.
Yep, there we go. Mm-hmm.
Some frost line on the methane tank. I'm mostly sure that the oxygen tank is also frosty. The problem is lower down in the booster sort of structure. There's all of the tank farm and everything in the way, so we'll probably have to wait a little bit more until that frost grows and be able to see that frost on the liquid oxygen tank. But most definitely probably already there. And also frost on the methane tank on the ship as well. You can see there frost on each of the tanks. So we have all of the 4 main tanks of Starship Super Heavy completely well underway in that propellant load sequence. Frosty, and they're gonna get even more frosty as they get more and more propellant on board.
As they get more further along. And this is something, by the way, that SpaceX has a lot of experience with now. Although they've only launched this stack 3 times, they have fueled these stacks many more times than that. So this is becoming part of, I don't want to say the routine, but it's becoming something that SpaceX has got a good understanding of, and they're really honing in the speed in which they can fuel and the reliability of the fueling process here. So we've noticed once they start going, they tend to be able to keep going there, given what they've seen. And Adrian, one of the things I've been thinking about here, we've been hosting the Countdown to Launch shows here live on NSF over the last week or two. We have not struggled to find things to talk about, because if I got you guys on, we can always find something to talk about. But it felt to me as though the run-up to this launch had far less uncertainty in it. It seemed like there's procedures in place now that are kind of getting locked in as to how this system operates. What are you seeing as an observer of this, insofar as SpaceX kind of focusing in now on the operational future of this rocket, where it's going from an experimental design to something that's going to become the design?
Yeah, obviously, like with every single launch, they will get a bit closer to where they want to go. There's not really a one final design, but there's one design where they at least get to the point where they can launch payload, they get to this operational phase. And with every single launch, we will now see, it's not this one-click launch. It's not, oh, we're doing 10 test launches, and the 11th suddenly will change everything. Every single launch from here on out is a iteration, and we saw this with the process. We actually talked about this earlier today, Alex. I remember that at some point they just said, "Oh yeah, we were targeting the 14th," and then that just kind of sticked. It like
right.
they just said, yeah, we are going for on the 14th, and basically as soon as they said that, as soon as they got that, we had this really methodical approach to the 14th. And yeah, it seems they're getting there. They're understanding this vehicle more. Of course, we are still talking about the biggest rocket of all time, and there's uncertainties with this. This is still a huge endeavor to fuel this vehicle. We are talking about 5,000 tons of propellant. It's getting this ready is still a huge challenge. And also, to put this caveat here on, could still things be wrong today. Like, something could go wrong during fueling. We always talk about valves. Valves are a thing. It only needs one valve stuck and frozen, and suddenly you have a problem. So this is an enormous achievement that they get this down to this all methodical approach. And yeah, I'm really happy to observe this, because it's fantastic.
And Alex, about a week or two ago, we had the Vice President of Development from ULA, which is a competing commercial launch provider, talking about their new Vulcan rocket. And one of the things I had asked him was, that launch of their first rocket looked so normal, right? It looked like it was on brand for ULA. Like, their rockets seemed to look and operate in a very predictable manner. And this one, being the first launch, just kind of went just like all their other ones did. And he talked about all the testing that they did prior to launch, all the simulations that they run. SpaceX, Alex, is a very different process, right?
Yeah, they try to get what it's usually called in the industry the minimum viable product, right?
Mm-hmm.
Where it's sort of like, what else is needed to at least get the minimum available to be able to do something, right? In this case, the something is get some data back, right? It is a really complex vehicle. Trying to develop this in a more traditional manner, where you spend long time to be able to analyze everything, that will take a huge amount of time, a huge amount of money. That time and money instead can be spent on doing some analysis. It's not like they didn't do any analysis, of course, but helping those analyses by taking real life data. Sometimes you have models and things like that, but having actual flight data, having actual real life data can help a lot inform those models. And so it is a very nice thing to have when you have such a complex vehicle such as a Starship, especially in the future when it's supposed to be fully reusable and everything. It's really good to have that capability of being able to try to do trial and error and trying to find the weak points of your system using that, because sometimes models can miss a lot of these things. It is complicated to go through every single detail and not miss something. And so when it is a much smaller rocket, a much simpler rocket, and especially one like Vulcan that draws upon a lot of the heritage from Atlas and Delta, it is much easier to be able to go through the traditional route, where you take a little bit more time with those models, and then your first flight obviously succeeds because it draws upon that a lot of time and a lot of heritage. Whereas these, you kind of, the failures are a feature of the test campaign, right? Of trying to develop this rocket rather than a bug. So yeah.
And it looks like we're still moving along here. We are about just under 33 minutes from the T0 announced time from SpaceX, and a lot of indicators are here that we're going to be pushing for this launch today. The fueling process is continuing, Adrian. I see that frost ring climbing up the side of the rocket. That means we're getting more fuel inside, doesn't it?
Yeah, and absolutely. And one of the next big steps that we are looking for at a not fully defined time, and it's actually an interesting part about Starship, is the fact that they will open the O&M hold down clamps. Because with some other rockets, you have the engine throttle up, and at some point the rocket computer, the onboard computer verifies go, and then clamps open, right? That's not the case with Starship. Starship, as we understand it, and this is like, there's also a bit of like reading into the countdown in here, is in a situation where you basically have the clamps will open at a certain time way before liftoff, and from that moment the rocket just stands on the pad. It's basically just secured by its own weight on the pad. And at the T-3 second mark, the Raptors will throttle up, and we will basically they will still have a thrust to weight ratio of under 1 until T-0, basically the moment where they will start to ramp up the engines. And the whole point of about T+2 seconds being liftoff, that's just the moment where the Raptor throttle up reaches a thrust to weight ratio of over 1. Because this rocket, again, there's no clamps. As soon as it has a thrust to weight ratio of over 1.0, it just goes.
It's physics. And you know what? That's one less thing to fail if you can rely on physics, right?
Yeah, I mean, and that's also it's this approach of like, why would you have launch clamps? I think it's an interesting design challenge to find launch clamps where you can throttle up about 70 to 80 meganewton, and the launch clamps are like, no, I got this, no problem. Right. Hard design challenge, and B, sure. I mean, if it's secured, just have it there, and if the Raptor, like, it's a self-verification system, right? Because if you have a thrust to weight ratio of over 1, well, then you can obviously right now go. So it's pretty simple. Kind of fascinating.
It is fascinating, and we're watching that frost ring slowly climb up the side of the booster there, so that's a good sign that we are pushing for a launch at almost exactly 30 minutes from now. Our clock is tied to the last announced T0 time from SpaceX, and the way they were approaching today's launch was a 110-minute launch window that started at 7 a.m. Central Time and is now pushed forward a little bit. We're now at 7:55 a.m. Central, but we still have a good amount of margin left in the mix here. So, Alex, what can we expect next now that we are basically in the middle of the fueling process? What happens after this?
Well, right now, what we are expecting, obviously, in the fueling process, we are obviously observing how the tanks get more and more full, more and more frosty. So obviously, trying to follow along with that. Right now, it's pretty much calm in that sense, if you think about it, because we're just observing, right? There's no major events, or at least another 10 minutes or so, where essentially the engine chill vents will start. That is the process where they chill down the Raptors ahead of full flow of the methane and the oxygen into them. So that'll be an important step on that timeline, because without that, the engines will get badly damaged, to be fair, right? So we'll see those vents on the ship not quick disconnect, excuse me. There are 2 lines coming down from the ship down to the booster that will be venting. We'll see that venting as well from our south cameras. It's up to operators, by the way. You should see some of venting as well nearby the tower, near the bottom of the tower. That is from the engine chill pit, as I call it, which is essentially the same thing as the ship, but for the booster. And so both the 33 engines on the booster and the 6 engines on the ship, then those will obviously go into that chill down process. You see some of that venting there on on the ship. It's quite amazing.
I don't know if we can have that shot that's tilting up start tilting back down again in a second, because I saw something interesting with the layout of those heat shield tiles. Maybe we could actually talk about it from the top here as well. If you look at where those fins are at the top, the heat shield kind of wraps around slightly in spot there as well. Alex, what's the thought process behind this? We have like a little area that's not protected and another area that is. What goes into deciding where all those tiles go and exactly how many they need? Because it looks like there's like one spot where there's just one little lonely tile there sticking up, right? Did they notice something on the prior flights? That part there is the most intriguing to me. Is that just based on the aerodynamics and where they expect the plasma to flow?
That is actually something that has not really changed much. The outline of the nose cone has changed a bit compared to 25, but 24 and 25 also had those sort of extensions into the leeward side, as you can see there on that flap. It's essentially just due to the geometry of the flap, right, and how the plasma will go around it. And so that is something that we need to keep in mind when installing those tiles.
And Adrian, just towards the bottom there, we've got two items of interest. One is the hot staging ring there, that open portion, which is basically the border between the booster and Starship. That was a topic of a lot of discussion on our last flight because people weren't sure how this would work. The stage separation on Starship changed from Flight 1 to Flight 2 in a significant way. Can we talk a little bit about hot staging and what that ring does for that process?
The hot staging ring is a thing that SpaceX has implemented, and I have to be fully honest, I didn't see it coming that they would just go to this at the second flight. But basically what happens is, so at the moment you not fire your engines while going to space, you lose against gravity. You kind of lose efficiency. So how to minimize this and how to solve a bunch of other problems is to basically throttle up your ship while your booster is still firing. So you never have this moment of coasting downtown. Even if it's just a few seconds, these few seconds matter. These few seconds make up a certain amount of payload. So what they basically do is they throttle up the ship while they throttle down the booster, and then the separation happens more by the fact that the ship has more thrust than the booster and then just glides off more than anything else. So that's a little neat trick that they use, and it helps with a lot of other things as well. For example, you have this whole situation in space that you have to settle propellant, because propellant as soon as you stop accelerating starts to basically go all over. So if you have bubbles, for example, in your propellant, they will also start to go all over. So what this basically, it's kind of like if you imagine sitting in your car. It's like you're accelerating. It helps to push you back, and it helps to push the propellant, in this case, back. So the propellant is already settled where it needs to be when the Raptors ignite. So just another neat little trick.
I think of that scene from Apollo 13 when they showed that separation on a Saturn V rocket in the movie, but the astronauts were thrust forward and then thrust back, so you don't get that with a hot stage, just like that. All right, so we are currently at 24 minutes, and one other thing I wanted to ask about, Alex, is the grid fins on Starship are out all the time, whereas on Falcon we see them be deployed on the way back down. How's that different here?
Yeah, the grid fins being out is not really a big deal, especially when they are in the orientation that they are right now. They're essentially in the sort of lowest drag as possible, and they're also they have indentations on the bottom that should allow them to essentially work on one way but not the other. So essentially those indentations on the bottom allow them to grab more onto the air. They give them more grip onto that atmosphere as they come in, so that gives them more control as they sort of use that. So when the air comes from the bottom of those grid fins, then obviously it helps, but when it comes from the top, it's not as it really doesn't do as much effect, right? And so you can think about that as basically again it's just different, right? So it doesn't really produce that much drag. And again, this is a really big vehicle, and so the little drag that it may produce, it's significantly counteracted by the fact that you don't have heavy systems to be able to deploy those and fold them back and things like that. You just keep them extended and simplifies a lot of the systems.
And we're seeing those frost rings grow every minute here, which is a good sign, which means that fuel is still pouring in. We are about 22.5 minutes from the T0 time, and of course there's a little bit of margin worked in here that SpaceX could put in place if they need to. And while we've got a second here, I did want to acknowledge a few more super chats that came in. Beth Sanders, $199.99. Thank you very much for your generous contribution here. Beth says that you guys rock, and actually the whole community rocks here, because this is a community effort. It was started by the community, and the community is very excited, I think, to see this launch here, as we have 130,000 folks tuning in to see our coverage here. And I can't get Beth's, there it goes, up on screen there. Also, it looks like we have the Jordy Viking, so nice of SpaceX to light the big shiny candle for my birthday. Awesome, it's great to have some birthdays here, and a very big candle and fireworks that will follow. And I say fireworks because even if the mission is successful, Starship and booster will be exploding, hopefully impacting the ocean and not in the air as the prior versions of this did. So we are anxiously hoping that SpaceX sticks to the schedule here. I can see my co-hosts backstage here. I can see their cameras. They are very excited here. You know what's funny, Adrian? Like, I don't know what it is about this program, but it feels like every launch is the first one. Do you feel like that?
Yeah. I think really, so how I always view this, and I also thought about this, why is it that Starship is so capturing? I think it's because they just built this like next to a public road, which means you have more time to connect these vehicles. Like, for example, we here at NSF, we have followed every single step of these vehicles. We have seen every single ring, every single stacking. We have basically seen every single test of this from the moment they were created to now. So it's like you have like a history with this vehicle. You can really follow it through every single step, and I think that makes it so much more relatable. You're kind of, and you also, and that's the other component, and that's you have predictions. You have like assumptions how something will go. You can really like it's exciting. It's unknown. So I think that's why it's always just so addicting almost to watch these Starship streams. And yeah, it's wonderful to observe this close, because there's currently, I would say, no other rocket in the world that you can observe this close all the time.
Yeah, even the NASA rockets, right, are harder to get to. Some of them are inside the vehicle assembly building for a while before we see them roll out. This is literally on the side of a road where you can set up cameras in a public place, as we have, and observe both from these farther away views to show you the full scale of the rocket, but we can also get in really tight there. And most of the footage that you see here is from NSF cameras that are maintained by Das and Jack and all the members of the community here over in Texas to make sure those those rockets and those cameras of those rockets keep operating. And in many ways, sometimes it feels like we're running our own space program here, covering things that are going on in space. Alex, we are looking at a nice image here of where all these tanks are located, and we're going to wait a second on that, but maybe I'll have Adrian talk about this. You know, we were talking about the liquid oxygen and methane tanks kind of getting loaded up. There's two little tanks there at the top. Is that the demonstration for this NASA component?
Not directly. So they will be probably involved in this, but in theory, they're just the header tanks that help with the landing burn. Because if you imagine the landing burn of the ship, the ship goes from a horizontal configuration and makes this very violent flip, basically to go into a vertical position and then land, hopefully. Not this one, but down the line. And these header tanks are basically there to, they are easier to have settled propellant, because imagine this main tank. That main tank at this point is, at the point of landing, is almost empty. And now make a violent 90-degree flip. You basically, your propellant is going everywhere. And it doesn't need to go everywhere, it needs to go in the Raptors. So that's why these header tanks exist. In this flight particularly, yes, most likely these header tanks are involved in the NASA demo, because, well, there's only two kinds of tanks. So if they don't want to put methane in the oxygen tank and oxygen in the methane tank, which I doubt, then they have to involve the header tanks for propellant transfer then.
So that is something I learned just now. So thank you. That's why I love hosting these shows, is that I can tune in on or get educated here as I tune in with you all. So we have some updates in the back channel here. It looks like Starship is 84% loaded up with its methane, 85% LOX, booster 63% methane, 66% LOX, and climbing fast. And is Alex ready with something?
Yeah, so I was listening in to the updates from the SpaceX, obviously. It appears that, everything remains go, weather, range, vehicle. But obviously, as they have slipped into that sort of window that they have today, they're looking carefully at the winds. That is sort of their concern. Still, weather is go, but as they were mentioning, they may opt to hold at the T-minus 40-second optional hold point. That is where they have sort of their, moment in the count where they could, in theory, hold if they want to. And so it seems like they may opt to take that option. That is totally okay. They have plenty of windows still, and definitely, that propellant load, as you can see, it is progressing really quickly. They are gonna switch to the header tank fill on the ship. The main tanks are almost complete, and so they stop at around 80% of that fuel and oxidizer load onto the ship, and then they transition to loading the header tanks. That's going to be important today, because one of the test goals for this mission is to transfer some of that propellant on the header tanks to the main tank. So that is going to be important to fuel them, to load them, so that they can obviously perform that test. You can see there a magnificent view of those 33 Raptor engines on Super Heavy Booster 10. Hopefully they all work today.
Right. They worked last time. That was the biggest thing, that we were so excited to see all of them lit up as they went up. And the nice thing with methane fuel, Adrian, is that it's very easy to see how those engines are performing, because they don't look like a big blotch of light. You can actually see each one.
Yeah, they burn relatively clear. Raptors are burning this purplish orange, and we could very well see on Flight 1, once they turn into a bright orange flame burst, that's usually a sign of a dying Raptor. So
right.
that was always good to see. And this mega Mach diamond that we saw on Flight 2, that we all observed, that's so visible. You can really see this shape, this complete perfect shape. And that was the one thing when, we three commentated Flight 2 together, and I know we were all three were completely stunned by the fact that they just worked. Not even a bit off. You had all 33 perfect were running. And I think that's the biggest thing I'm looking forward here. Can they do that again? Go ahead, Alex.
I was actually going to say that we were able to see there the engine chill pipes on the ship. There we go, back to them. You can see those pipes very frosty. They have started the engine chill. That is good, expected. This is basically at the point that we expect that. Another thing that now they have starting to load propellant on the header tanks, we should see. Oh, there we go.
There we go.
Venting from the header tanks. That was exactly what I was gonna say, because around this time in the count, that's when we see that activity from the header tanks. Good that it is still the case. Good that it is progressing. That is good news. Again, while they're still looking at the winds, they may opt to choose that to use that T-minus 40-second hold point in the count. But for now, weather is go. So let's pray for good winds today.
That's right. The winds are the only thing. But at the moment, the weather is go, so that's good. But the winds are the one thing they're keeping an eye on. They have to stay within certain limits. But
well, there you go, everyone. Looks like we're way ahead, well into refueling. Everything seems to be go for the moment. Even the clouds seem to be parting. You can see there's still a bit of wind blowing those clouds around. Yeah, exciting times. Hey, Michael.
Yeah, definitely. Can't wait for this one. I think Lou was trying to come in on the channel on the.
Oh, was he? Sorry, I do apologize. Oh, hello, Lou.
Hey, everyone.
Hi, Lou.
Sorry, I missed you.
No problem. Susan and I were in a little cafe here in Florence, and I just happened to look on YouTube, and I saw that you only had a few people on. I said, "My God, how long can you talk about this?" I told Sue, I said, "I know Daz is on, so they can talk for a long time, but
what are you saying?" No, we've basically, because they've been pushing back the time, we just sort of like left the stream for running with the sound, and people have stuck with us, and I thank you all for that. Ian, who we got here? Let's have a look. Astronoobly. If you're still in the chat, everybody, please put your names in, and then we can all say hi to you. And thank you very, very much for sticking with us. Always a Daydream Astra, so that's Rachel. Thank you.
Hi, Rachel.
And there's a message for you, Lou, so I'll just post it up for you so you can see it.
Yeah, I've been doing a lot of traveling, and
yeah,
I think I just need to retire and do what's important.
Yeah. That's right.
Yeah. So, what are you all excited at this launch, Lou?
I am. I'm excited for every launch that extends our knowledge, our understanding, and our reach into space. Today, however, I've been more preoccupied with something else, and that, of course, no big surprise, is the Voyager mission. I got a contact by a colleague who has some of the original artwork and some original audio tapes that created the record that's on the Voyager. And we're looking into ways to archive this very historic material, and also to keep it ready and accessible for generations to come.
Right.
Yeah, that'd be lovely.
And with the 50th anniversary of Voyager coming up.
Yeah.
50th anniversary.
Yeah, exactly.
So I contacted some of my colleagues, the ones who are, left on the Voyager infrared team, and I'm putting together a reunion with we'll do some video taping of their experiences, and hopefully that'll all be good. So that's been occupying my morning, besides being in Italy.
Yeah.
Yeah, lovely job.
How is it being in a similar time zone to us?
It's weird. Maybe it's a little too close. A little distant sometimes is a good thing.
Yeah, see, now you're in reality. In the right time, in the right reality.
Yeah, that's nice.
Well, everything seems to be progressing well. We've got under 10 minutes to go, nearly just over 9 minutes. So it's fingers crossed. I think what we'll do is we'll just chat for a few more minutes, and then we'll go over to the live commentary, and then we'll come back. We'll leave our microphones live so that you can hear us whooping and wailing and all that, and everything else that goes on when we have a live launch. So it's exciting times. Things are moving on. And I must admit, I was a bit of a doubting Thomas. I wasn't sure it was going to leave today.
Yeah.
But it's certainly, everything's going fine. I mean, look at that. Look at all that venting and those frost lines. Well, they're not frost lines. It's a popsicle now, isn't it? The whole thing is absolutely frosty. You wouldn't want to stick your tongue on that now, would you? Right?
I don't think so.
Just so close to launch.
I double dog dare you, hot mama.
Oh, don't dare, please don't.
And Luke, I was
time. It's got me in trouble many a time. Just like to say hi to Sandra, and Ian, and as I said before, Daydream. Thank you for all sticking with us. I see there's quite a few of you live.
Yeah, I was saying to
Yeah, carry on.
Right. Sorry, Lou. I was saying to Daz earlier. It's nice to have a real spaceship called a Starship.
Well, isn't that the deal? It's part of being, I think it's part of being human. Just, you're born, you're given a body, maybe you're given a few tests to solve in life.
Yeah.
Not much, but part of what you're given is an interest in growth and extension. And if you've ever been at a lake and tried to skip a rock across the pond, you know the feeling of extending your will beyond your physical limits. Nice. And we're explorers at heart. We've always been explorers, and this is part of the human condition right now. This is what if there is such a thing, this may be what we're here to do, extend our consciousness, our will perhaps out into the universe. So here we are doing just that.
Yeah.
Kev's just saying hi to you, Lou.
Yeah, so many nice greetings. I really appreciate that. Thank you so much, guys.
Right. Okay, I think what we'll do now is we'll what are we down to 6 minutes? When we get to 5 minutes, we'll go into we'll go back to NASA space flight, and we'll listen to the commentary, and hopefully we'll be looking at a successful flight. As I said, they're pretty confident themselves. I mean, the second test flight was far more successful than the first, as we've mentioned before. And they got so close. They're very confident this time. They were also going to be hopefully doing some demonstrations of different things when they're actually in orbit, i.e. opening the payload door, relighting a Raptor engine in space, being able to move fuel from between tanks. Of course, we'll need this for when we do the refueling. And of course, this one's coming back down in the Indian Ocean rather than at Hawaii. So I think it's a shorter flight than what the other ones were planned for before. And the reason it's in the Indian Ocean, it's a bigger area, so that it gives them a chance to do these things. And also these, of course, these are going to end up in the ocean. The Starship, they hoped, will explode on impact. And the booster, they will probably be doing a soft landing. I did hear them say earlier on that they hope that it will be destroyed on landing. So to me, that doesn't sound like a soft landing. So maybe they're just going to drop it straight into the ocean. So look at all those. Oh, you probably can't see it yet, but there's loads of engines there. And we hope all 33 of those light again, like we saw with the second launch. It was such a beautiful sight. And then look out for the diamonds, the fake diamonds in the flames. And let's just hopefully we'll fingers crossed for a successful launch, and we get this going, because so much depends upon this for our future expansion.
Daz, as I remember, I think this is right. One of the problems with the Soviet Union lunar program was that their big booster had many engines, and therefore many potential points of failure. And of course, there are other issues as well. So I hope that's not what's happening here. But now I know you guys prepare for this, so I know you have your script for if this is successful, and then you have a second script for if it's not. So I'm hoping you get to use the first script.
We're winging it. We're winging it. We're not like a president. We've got two scripts just in case things go well or not.
Yeah, I'm Daz's wingman.
We're just winging it. Yeah, if it's a failure, Michael will just slip off to one side and disappear. So leave me to it.
You have to say space exploration is difficult, and every
it's hard.
Successful or failure gives us new information to reach to the stars. You have to be like That's
It's all about data. It's all about data. Right, I'm going to go back to the live stream now, and we'll cover the launch, and then we'll pop back in. Either way, we'll have a quick chat at the end of that. So, see you on the other side, and let's just hope, fingers crossed, it's a success. So, let me just get get some sound on here. Oh. One me a second.
Before, I guess they push the button, or the button pushes itself.
Yes. And I also want to quickly point out, because I saw some people, being concerned about, like, oh, will we talk about launch and everything? Like, as soon as we see the deluge, as soon as we see like this rocket getting ready to fire, we will of course be quiet and make sure you hear these beautiful raptors. So we are aware. As soon as we see the deluge, you will see us on the other side.
Right. We want to give you something to listen to while we're all waiting together. And what's really fun about rocket launches when you're watching them in person is that it takes time for the sound and that shockwave to approach. So you will see us, well, first of all, you won't hear us. You will see the rocket launch, and then probably about 20 or 30 seconds later, you will hear the sound arrive.
Well,
some of our cameras are a little bit closer.
Yeah, I'm not sure about that, because some of our cameras are very, very close. So I wonder.
Some of them right there.
Yeah, so I think the sound will be basically at ignition. We will see. It's certainly interesting, and there we see the beautiful flight stack here, as they are.
We are 2 minutes and 30 seconds. Yeah, looks like we're ready to go. So Alex, the winds are the only thing they're keeping an eye on right now.
Yeah, they are progressing into that. Basically, you can see there the tower vent has come back, so that is a good indication that they have completed the propellant load on the ship. They are clearing out those lines. They are purging them out of propellant as they go into the final 2 minutes of the count. The OLM vent has also come back, so the rocket is now fully loaded with propellants, 10 million pounds of propellants, about 5,000 tons. It is a massive rocket getting ready to fire for a third time and heading to space. Quite amazing.
And
but yeah,
it's totally
remember,
amazing.
we
have
are 1 minute away
this.
from that optional 40-second hold. So let's see what happens.
Let's see what happens. And I am dying to see one of these in person. It's got to be incredible to watch. So, all right. So we are just waiting on so we're at about a 1 minute mark here. Again, we're expecting a hold potentially at 40 seconds, but if they decide to go through it, they go through it. So we're going to keep watching. Yep, very carefully here. If SpaceX feels they're ready to go, they're going to go for it.
It looks like they may have a chance of going through and not holding.
All right.
So eyes on the base of the mount for that detonation suppression system to activate.
And once that water deluge...
Go
ahead. No, sorry, go ahead.
No, it's basically the what we will see is this deluge system will fire at about T-minus 25 seconds. That's where this whole system will activate, and then we will see the Raptor startup sequence at about T-minus 3 seconds. So it's gonna be rather quick here if this is really happening.
And we're going to wait for that water deluge. We will be quiet once that happens. We are past the 40-second mark. Have we heard of a hold?
Detonation suppression system active.
No hold. All right, we're going. And it looks like we're at 10 seconds.
Whoa, look at that.
Power.
Look at those diamonds.
All seem lit.
Yeah, it looks like all of them are lit. Go, baby, go.
There's some great views coming up through the clouds.
Oh, you must be watching a different...
I'm watching the live feed from SpaceX.
Look at that. The heart's pounding.
I know. Yeah, you're about 40 odd seconds
Yeah.
line or so.
We don't seem to have any sound from them.
Sorry, that's SpaceX now.
Is this a separation event here?
There should be very shortly.
Yeah, very shortly. We'll see the hot staging.
Yeah, it's hot staging. Is it hot staging now?
Ah, look at that.
Oh, look at that. It's already got the grid fins extended.
That's a lot better than last time, isn't it? That's a lot cleaner flight, isn't it?
Yeah, look at this.
Oh, hang on. What's happened? It's good that it's in daylight now.
Yeah, and it's nice that the clouds have parted as well, so they can actually track it.
Actually track it and
Yeah,
see what's going on.
All right, so amazing. And I will love to get some feedback from both of you here. I was watching you, so I can watch your cameras. I saw some. I was excited too. I counted all the engines firing. Does that look to be right, Alex?
Let's watch out that hot staging, boy.
Yeah, but everything so far looks good. There's hot staging.
Hot staging.
There's hot staging.
Oh, wow.
What a great
Are we getting on boards for hot staging? Look at this.
Oh my god.
Oh my goodness.
Yeah, there you can see basically the preparation for the ignition of the Raptors.
Oh.
Should be up.
Right.
Yeah, with their separated.
Oh my god.
All right.
So we're looking at now is the.
It did it.
Yeah.
So this is where the booster.
Booster is coming back.
All right. So that was the big issue last time, right? They couldn't get it to come back.
No.
So
yeah, it looks like progress.
And Starship is still going.
The booster is in the boost back burn. The ship has ignited all 6 engines. We have, so much progress compared to Flight 2.
Here's the booster.
They're onboards in space.
And we have onboard shots from Super Heavy.
94 kilometers.
Oh boy,
So,
this is such
yes.
amazing.
Yeah, you
Look
can
at
see
that.
the
Look at that
engine
velocity, guys.
graphic. They're all lit.
Could you see the
Slow
roll
down.
control there? Did you see the
Right.
roll
Yeah.
control?
Of the
Oh, it's the
engines.
boost back. Look at the boost back. Look at how it slows itself down.
And shutting down.
Boost back shutdown? Is that a
nominal? I guess.
That's nominal boost back shutdown?
Yeah. That's
Okay.
fantastic.
Well, I think the fact that
those used from the ship
both
as
components. Yeah, and both components are still
Okay.
intact. So that's a
Wow.
good sign. What a beautiful view
Okay,
of
so
the.
now Super Heavy is in space. It has crossed 100 kilometers, even the McDowell
Yeah.
line and everything.
Hey, that's good.
You've seen some
Alright, so
venting
now-
there.
Yeah.
All 6
we
engines
seeing
on the
ice coming
second
off, or is
stage are
that
still lit. If you look on the
material?
right-hand side at the bottom,
Yeah.
I'm
That's
also sure that it's made
and it's still accelerated.
system activating, which is normal.
Everything is looking good for both the first stage
booster
on
has
the left-hand
passed
side of your
halfway,
screen
and now
or
it's
the
coming
super
back
heavy
down.
booster,
That
as well as on the
going up.
right-hand side of your screen, that is Starship, or we also refer to that as the ship.
And yeah, Starship is continuing to
Now,
go.
the boost back burn
into that
was the
victory.
first of 2 burns required to return it to Earth. The next one will be the landing burn, where all 13 center engines will initially ignite and then transition into a 3-engine burn to help slow it down. Now, just as a reminder of the Stage 1 test objectives, we're looking for controlled ascent, which we have so far. Stage separation, which, gorgeous, we cruised right through it, as well as
on a nominal trajectory.
good news there telling us that the path that Starship is on is good. Now, Starship's second stage is still firing its engines, and as you heard, following planned flight path, The ship objectives, we're looking for hot staging. Again, cruised right through that. We're looking to demonstrate controlled ascent as well as orbital insertion. Now, the bottom right-hand corner of the screen shows the ship engine graphics, so be sure to keep an eye on those.
Yep, Kate, like this is just a phenomenal test so far. Super Heavy is performing beautifully today. It's on its return leg of the journey. Ship continuing to burn its 6 engines, those larger circles, the Raptor vacuum engines, the inner circles, the Raptor sea level.
I'd just like to say hello to Miss Fox's reception class at Bears Car Primary School. Thank you for joining us. I hope you're all excited and enjoying this. We certainly are. We're probably acting the same sort of age as you all are at the moment. We're all giddy and we're all excited. So welcome, and it's nice to see you all. Say hello to Miss Fox for me, or wave. Thank you. Right, let's go back to the thing. Thank you very much.
That's a great view there of the fins.
Yeah.
Look at that cloud layer.
Oh, shaky. Bit shaky.
Yep.
Look at the fin going.
Trying.
It's trying, certainly.
Well, it's
I think we might see some flight termination.
We see some Raptors.
And there we go. It hit the ocean.
Yep. Right. But that was,
that was a bit late.
Yep.
Well,
No. Maybe needs bigger
lessons
fins.
to learn for the next time, but man, did it go much farther.
So much better.
Is that like
Look at the ship. Look at the ship. If this, we are already in the booster stage. The booster stage is already past what they achieved on the last flight by miles. Now we are looking at the ship. Remember, the ship last time had an issue around this phase where they started this liquid oxygen dump and they started a fire, which then resulted in the ship basically having a fire and having to terminate the flight. So far, this looks good.
Yep.
Yeah.
All the engines
and it
are
looks
burning.
good. Literally, look at these views from space on the Starship.
Look at the TPS.
Yeah.
I don't look at the TPS. I don't see missing tiles.
Boy. Okay, we are approaching the speed that Flight 2 got to, 24,000 kilometers per hour. And it just crossed that. So we are better now than Flight 2 for the ship as
146
well.
kilometers high.
So what we see here now, we've seen now really a progression, right? So we've gotten
All
further
the
and
engines
further
are
on
still
each
lit.
flight, and
they've
now it'll
just
be
knocked
getting
off.
that landing burn right for the next go around. But
3
Starship
engines have shut down.
is still.
Yeah, we need 28,000 kilometers per hour, I think, to achieve
And
that.
now we've got
Unbelievable.
I'm sorry, actually it already
There
has.
they go.
And shutdown.
There we go.
Oh, right.
There we go.
So we're up.
It's in space and it's...
Now we wait for orbit normal conversion.
By the call out and from the crowd behind us.
Nominal over insertion.
Starship's 6 Raptor engines have successfully shut down.
Right. And one of the
These views are
tests
incredible.
is they're going to relight
These views
one
are
of those
absolutely incredible
engines.
here. So
it'll be the
have you
first
seen
time a
good orbit
Raptor
here,
engine
gentlemen?
has ever been relit in space.
It is. I mean, it is.
It's going to do some, like I say, some tests now. It's going to do its
so now
fuel flow. So, which
And
is
now the
what
two things that
it's
they're
got like
hoping to achieve
a
here is the opening
demonstration of being
payload
able to
doors,
refuel and move
Adrian,
fuel
and then
around in
also that
space.
fuel transfer test.
They will be opening the payload
That is
door.
correct. That's
Again,
the
the
first
first
two
time the
steps that we will
payload
see
door will be
here.
opened.
I'm so looking forward to see. Like, this is
And then
astonishing.
it'll bring itself
They
down.
are
And as they said, they
cruising
can't see any
past us
tiles
and are
missing
just
at all.
getting
So fingers
things
crossed
done here. It's
full re-entry.
honestly mind-blowing how good this so far looks.
Oh my God, the views of Earth from Starship are amazing. I gotta say, this is such.
And do you think these
I'm
are
starting
coming?
to get a bit emotional, I guess.
Do you think these are coming now from the Starlink antennas that
10
are on
minutes
board?
into flight now.
Yeah, one thing that I'm looking here, I believe we're looking at the aft end of the ship. You see some of those vents. The interesting thing is we sort of had these vents, at least I had those vents in mind. They seem to be venting from the bottom of the liquid oxygen tank. There's three vents that are on the bottom of the liquid oxygen tank. I don't want to speculate, obviously, but that's sort of what it appears. Without any official confirmation, I obviously cannot confirm that it is the case. But they do suspiciously look like those vents that we saw prior to this flight, during the operations of moving ship around. We should be approaching the moment of that opening of the uh, door on ship 28. Remember, this is one of the milestones of today. This is not the end of the flight, right? Now we're
Right.
approaching all of those milestones that
The
they wanted to
images are
hit on
amazing.
the closed
Yeah.
space here towards the Indian Ocean. So
those engines are
if
literally
those
hot.
also
we
go well, that's nice.
Yeah, because they probably didn't reach full
We're seeing a
speed
slight
because, like I said,
slowdown here.
they're looking to
It's that.
actually
My God, this
come
is
down in the Indian
unbelievable.
Ocean. They're not
So
going
let's look at the
all the way
timeline
to
here.
Hawaii
Let's look at
this
the timeline.
time.
The payload door
So
should
it's not
open
going
in
that
30
far.
seconds from now.
Okay.
So
And that's a big milestone. That of course will prove Starship's capability to deploy payloads, which is important for the commercial aspect of Starship. And we can honestly say it is a Starship now. It is in space, in one piece.
it's amazing.
And then, of course, the other thing that we are looking for after that payload bay door would be the movement of that fuel from one tank to the other.
PEZ door is opening, so that's great.
First test.
One of our test objectives today is to open and close that PEZ door. That's where we will deploy Starlink satellites from in the future. So great news there that test objective is already underway. So come back here, stick around till T plus 40 minutes for coverage of Starship's deorbit burn demonstration, followed by its reentry and what is sure to be an exciting splashdown.
So, I like the elevator music.
Yeah, elevator music.
So what do you think about that, folks?
Oh, brilliant. Absolutely brilliant. Yeah.
That was fantastic. My heart's still going, actually. It's sort of like almost unbelievable that and the images were absolutely fantastic.
I mean,
everything was so perfect.
I was just thinking those images flying through those cloud layers were absolutely amazing.
Yeah, it. I mean, it's just everything went so perfectly. Even the splashdown of the booster.
Yeah.
You could actually, just before it cut out, you could actually see the waves. Just for a fleeting second, and you think, oh, absolutely fantastic. How long did you say before we come back to
T plus 40 minutes, I think they said.
40 minutes, because so we got a little while yet. So hopefully just keep an eye on that, the graphic for the second stage engines, to see when they do the burn test, see if it ignites. But
I'm watching something interesting here. If you look at the lower right part of your screen, you see the speed.
Yeah.
And the speed is gradually diminishing, as you'd expect with other forces on the spacecraft. However, I'm also looking at the altitude.
Yeah, it's climbing.
And the altitude is climbing. So I'm trying to think, what is going on here? I guess in an elliptical orbit, you can have that.
Yeah.
Right.
Well, it's almost at the height of ISS, isn't it?
And there's an empty launch tower. Fantastic.
Oh no.
Oh, and no, never to miss an opportunity. NASA space flight have got their new merchandise for the re-entry club.
I'm sure they all bought Space Oddities hoodies as well.
Oh yeah, they got yeah. This is what they go to work in, but the Space Oddities gear is for going out, the posh stuff. So absolutely fantastic. So. We'll just keep an eye on everything. Keep an eye on the infographics disappeared now. For when they do the engine test. I mean, even if that fails, it just, they've achieved so much. You imagine the data they got pouring in now, in which they've got to analyze, check everything, and it's absolutely fantastic. These engineers, they've been, working so hard to get this. And to be honest, I think it's really strange that they've managed to achieve this in just 3 flights.
Yeah.
That was strange. Somebody sent a message and it's cut off the. Let me just turn this back on.
You could say third time lucky.
Yeah, exactly. It is absolutely. It's an amazing achievement. So, what are we looking at here? Is this inside
This is
the
live image.
Oh, is that where the payload door is?
Oh yes, it looks like it's looks like it's open, doesn't it? Yeah, because it looks there's a big gap there. So
it's moving. It's moving. As we speak. You see?
Yeah, you can see. Yeah, you can see the sun. The sun.
Now that could be the sun angle. It could be rotating.
Oh, yeah, the sun angle. Yeah.
But that goes to show the door is open. So let's just hope they can close it.
Well, either that or they forgot to nail it down.
That is fantastic. So that's so they're just waiting for acquisition of signal. But yeah, it's but that is so amazing what they've actually achieved, and how they've come on. And like I said, I know they're already looking at the 4th launch. I think the way things have gone, that will be very, very soon, a lot sooner than later. I mean, we've only waited 4 months for this one. So I reckon it could be sort of like a month, maybe 2 months at the most, and we'll be seeing this again.
So in 50 years or 100 years, when the history of space exploration is published, this will be a page or a paragraph in that book, if they still have books. This is a part of human evolution, right?
Exactly.
There will be a form of books, won't there? People will still write.
Well, you don't know. It'll be telepathy, but no, it's as you said, this is one of the stepping stones in the history of space flight, and we were here. They'll be talking about the Space Oddities coverage for years to come. You can see, yes, I can see they're on the screen now, but you can see that they're stuck for words, to be quite honest. You can see they're so stunned, the lads from NASA space flight. So
all I can say, Daz, I was there.
Yeah,
we were there. Yeah.
We'll tell our grandkids that we were broadcasting, that we were streaming this on YouTube, and our grandkids will say, "What's a YouTube?"
Yeah. And what's streaming?
Yes.
What's streaming? We get it direct to the brain now.
Yeah, exactly.
So this is a fantastic moment. And we've got to just to warn everybody, nobody email or text Andy. He wants to watch this without knowing the result. How he's gonna be able to do that without finding out is, I think, it's an impossible task. But he wants to watch this without any sort of like idea of what's going on. So, which is fair enough. I mean, this has been so exciting, and it just seems within 10 minutes that was it. It was done. Job's a good one, and I'm stunned myself. I really am stunned myself.
Yeah, what was all the fuss about?
Yeah, well, when they do it the first time, but no, it's absolutely amazing. And now it's onwards and upwards. As I said, we can expect the next flight very, very soon,
Well, we've been saying, it seems to me that if I go back 10, 20, maybe 30 years, and NASA or some official at NASA is asked, when are we going to Mars? When will people set foot on the surface of Mars? It seems to me that it is always 20 or 30 years away. and that window just keeps moving forward.
Yeah.
But with successes like this, maybe that will change.
Yeah.
Maybe that will change. Maybe it's sooner than we think.
I mean, we're all on. We all know it's with space is hard. It's very, very difficult.
Yeah.
It's always baby steps, but this is one big step.
And I was watching. I remember it's got to be getting on for 5 years ago. I was watching a documentary program about humans going to Mars, and at the end of that program, they said the first person to set foot on Mars is probably already born today. But
yeah,
that was 5 years ago. But you could probably say the same now.
Yeah.
So,
So they're probably 5-year-old now.
Yeah.
And maybe somebody in Mrs. Fox's class.
Exactly.
You never know.
No.
You never know. And I hope you all enjoyed that as much as we did. As Ian in the chat put, we're all big kids. We love this sort of thing. I'm slowly calming down now. That was absolutely amazing. Now we've just got to wait. What's it, about 17 minutes, and we'll be looking for re-entry.
That's good math right there. Yeah. Daz.
Do you want to put our video back on the thing, Daz?
Sorry?
While they're waiting signal, you want to put our video
Well,
back?
we'll come back to, just come back to thing for a minute.
Yeah.
There we go. Yeah, so, sorry, Lou, what were you saying? You were breaking up.
Oh, I was just complimenting you on your math skills. You said
Yeah.
Oh, sarcasm, isn't it great? Yeah, well. Yeah, at least we do proper maths with an S on the end. Anyway, so yeah, we've got the re-entry to look forward to, and if that is a success, then more power to the railway. And also, we got the reigniting of the Raptor engine. So I'm surprised actually they didn't have with all the Starlinks how they've lost signal acquisition. Lost the acquisition of the signal. So that is strange, but you can't expect everything to work every time.
Yeah.
But I'm just trying to think where they would get acquisition from if they're heading towards the Indian Ocean. I suppose that could be somewhere in probably South Africa, or I think it's not far enough for Australia.
No.
So we'll see. We'll get things. But as soon as it comes back, we'll have a look. I mean, at the moment they're just showing. I can see on the little thumbnail the launch pad, and it looks totally perfect. No excavation, no holes. In anywhere, all looks so it's intact. But of course, only closer observation will tell us that everything survived. Because of course we can always remember the first launch, when basically the Starship just sat on the launch pad, was very slow moving off, and the reason for that is it was digging itself a hole, and which of course caused lots of damage. It spread debris over quite a wide area. Also, the exhaust cloud and the dust and everything traveled a long way on the wind and that, so caused a lot of problems. That's why we had to wait so long for the second launch. It was 8 to 9 months, wasn't it, if I remember right?
Do I remember correctly that the first launch did not have the water spray?
Exactly, yeah. It was. They decided, it was a decision made right from the word go. They were not going to have a flame trench or a water deluge system, and they thought they designed the concrete pad sufficiently strong that it would survive these the power that was going to come out of these 33 Raptor engines. And of course, it just sat there for a while and just dug a great hole. I mean, it's like anything else. Once you get a crack and you force a pressure hose or anything into that, it just opens up, and it made a very big hole. And of course, it damaged some of the infrastructure as well. If you remember all the dents in the holes in the tanks and everything.
And rocks strewn all over the place.
Exactly. And this is why the environmentalists got involved again. So we had to have all these investigations. Which is true. It's true. So, but the thing is, I think the idea of the deluge system, like we've got, which is sort of like the upside down, the
Oops.
Something coming in?
I think we've lost Daz.
He's frozen.
Yeah.
He must be cold. Well, he will restart. I think we're still on. We're
still live. Yeah.
Yeah.
Yeah. So I think.
So I haven't looked into it, but I wonder what the next stage in Starship tests is. Perhaps it's an orbital flight.
Yes, let's hope so. Yeah. Yeah. So.
And then we have Artemis.
Yeah.
Artemis 2 coming up, I think, near the end of 24 now? Or has it been pushed into 25?
I believe it's now towards the end of 25.
Okay, so things are getting pushed a little bit forward as the realities of everything they have to do to make this a successful, safe mission come about. Okay, and then that would mean that Artemis 3 probably no earlier than mid to late 26.
Yeah. I would think so. Yeah. Yeah.
And
they've been on about the delays to Gateway as well, haven't they? You know, so what's happening with that lately? I'm not sure.
And then I haven't heard too much lately about the Lunar Gateway.
Yeah.
I know that's not scheduled to be in operation for Artemis 3. I don't think it's scheduled to be in operation for Artemis 4, but I think original plans were to have that as a transfer vehicle in orbit around the moon for Artemis 5.
Yeah. Okay.
Lots of space exploration happening right now, both from NASA and private industry and their partnerships. So exciting! Such an exciting time to be alive.
And I think it's good to get the private industry involved with this, because government organisations can't do it alone anyway. So, you know, or they can, but it costs a lot of money for the taxpayer.
Well, they did, of course, for the in the very early days of space exploration, right?
Yeah.
It was all NASA or perhaps even all ESA and so on. But I think using all the talent that's available with all of the benefits and difficulties given each one's administrative structures, I think is the right way to go.
Yeah.
Involve as many good minds as possible.
Send a message to Daz.
You know, I have this image in my mind that Daz, who's a great orator for our program, he's just continuing to talk. He doesn't know he's not on yet, not streaming. And he's wondering why we're not interjecting, but he doesn't care.
Yeah, I know what you mean. Yeah.
He's launched.
See, he's got to close the show, of course, because he's still live on YouTube.
Yes.
And I believe we've still got 11 watching.
So this is human space flight, human exploration. But we have many things, many more things going on for robotic exploration. We have a Europa Clipper launch.
That's right.
Is it this year? End of this year?
This year, yes.
We have Some milestones for Parker Solar Probe. We have a launch in 26 or 27.
Yep.
Or Dragonfly to Titan.
Yeah.
And of course, some other great observatories, Nancy Roman Observatory.
Yep.
So, and that's just space flight. You know, we deal with space and space flight so often with James Webb and Hubble and launches and so on. But there's an awful lot of excellent astronomy that is done from the ground.
Yeah, that's right.
Large observatories, and which are in a position where you can swap instruments in and out with relative ease, relative to what you'd need to do on a spacecraft.
Of course, there's the talks of which is that there's the European Extremely Large Telescope, isn't there, in Chile?
Yes, and I'm still holding out hope for the TMT, the 30-meter telescope on Mauna Kea. I know that development has been slowed a bit for social, cultural reasons, but I'm still holding out hope for it.
Yeah. Yeah. Mm-hmm. So I don't know what's. Okay. Well, I'm going to sign off actually, Lou. But I'm not sure what's going to happen with the live stream.
Yeah, I guess if Daz began the stream, who knows? It may just be blank screens for our viewers. That wouldn't be good.
Yeah, I think the viewers are slowly dropping off, aren't they? It's gone up now.
I can't tell. I just see the chats.
Yeah.
But I think we can all say that this was a successful test mission in what appeared to be all respects.
Yeah.
And so they'll be analyzing that data. And it looks like all, how would you say it? All clues are, all paths are open.
Or maybe, what about all engines running?
There you go. There you go.
Right. I'm going to sign off now anyway, Lou, so I shall see you soon. And enjoy the rest of your trip.
Thanks so much, and thanks to all of our Space Oddities viewers for supporting us and for logging in and being the best part of our week. We really appreciate it.
All right.
We will see you Tuesday.
Yeah, okay. See you then.
Take care all.
Bye.